Okay, so pre-deployment phase is done, configuration is done, so now let's start the survey. So I will start the gaps. The gaps is now on the pole, and we will do the first 5 minutes alignment, which is needed for the gyro compa alignment, and then we will start to track the beacon on the ROV for the survey. Then I will explain you the acoustic cycle underwater. Okay, so now you can check on your GAPS Web MMI the status of the alignment. Here, on the right side, you can see the alignment time. This is the remaining time for the full alignment. On the gyro compass status, you can see here you are running the alignment. The status is then in orange, just to give you this information. When it will be ready, all the status will go to blue, and then you can do a second alignment, about 20 minutes to finish the gyro compa alignment and start your job. Okay, during your survey, you can also check the navigation data in the Web MMI. This will give you the status of the heading and attitude, system status with position, if the GAPS is in tracking or not, and here you have also the GPS information with the quality of the GPS. If I do a start tracking, then you have here also the transponder information that you will see here with latitude, longitude and depth. Then you can check all the value in real time. Okay, you can see here the alignment time will be ready very soon. So we will just check that everything will come into blue in 7 seconds, 6 seconds, 9 seconds, 4 seconds, and now. Okay, you can see you are in final alignment. You receive your GPS, and your UTC data, then you are ready to start the survey. I can do a start tracking, go in navigation data, and check all the status. You can see here heading and attitude, system information with position of the system. You can see acoustic is on. Here you can see the noise level on the 4 hydrophone, the GPS status, and all information regarding the transponder with latitude, longitude, and depth. Okay, now the GAPS is interrogating the beacon, and we are doing the survey. The ROV is doing its inspection underwater, and let me explain how is working an acoustic cycle. The GAPS interrogate the beacon. This is the first travel time. The beacon receives the signal and go in a silent mode. This is the turnaround time. In our example, this turnaround time is set to 90 milliseconds. This is perfect for shallow water application. After this silent time, the beacon replies to the GAPS. This is the second travel time. Then the GAPS receives the signal on the 4 hydrophones and computes the absolute position. During this time, the beacon goes in another silent time. This is the blanking time. The blanking time is set according to the recurrence. In our example, the recurrence is 1 second. And we say we keep an open window, listening window on the beacon about 200 milliseconds. So to calculate the blanking time, we do 1 second minus this 200 milliseconds, and it gives 0.8 seconds. This is the blanking time. This cycle of 1 second will be repeated during all the survey, during all the job. Okay, so now let me focus on the GAPS very unique design. We interrogate the beacon and the beacon answer. This is the second travel time, and in fact you will receive travel time separately on the 4 hydrophone. then you have 4 different travel times. In the same time, you also have angles and phase measurement. If the ROV moves underwater, then you have the same calculation with 4 travel time reception, angle, and phase measurement. That allows the gaps to calculate a very accurate transponder position. Okay, I can remind now that the gaps have a 200 degrees aperture. That means you can track your ROV even in horizontal condition, and due to this very unique design also, you will continue to calculate a very accurate position in horizontal position in shallow water. In the survey, we also have the TMS. So I can remind the configuration. When you interrogate the beacon in F1, you have the answer of the ROV and the answer of the TMS. The 2 beacons will not answer at the same time because we have set 2 different turnaround time on the beacon. The one at 80 milliseconds will answer first, and the second with 90 milliseconds will answer just after. We also can do another kind of configuration. You can choose to separate the beacon frequency and use 2 different frequencies on the beacon. You can interrogate the ROV on F1 frequency, and you can interrogate the TMS on F2 frequency. Then every 1 second you will do F1, and then F2, then F1, and then F2. But in your application, you really want to have good refresh on the positioning on the ROV. And finally, you don't care about the TMS, which is just below the vessel. And there is a specific tool for that, which is the repetition factor. You can say you want to interrogate more the ROV and less the TMS. In that case, for example, you can set the repetition factor on 5 on the ROV and 1 on the TMS. In that case, you will do 5 interrogations of the ROV and then 1 on the TMS. On the cycle, it will do F1, F1, F1 5 times, and then 1 F2, and then again F1 5 times, and then F2. Then you have a good refresh of positioning on your ROV, but you also interrogate sometimes the TMS and verify everything is okay on this side. It can be a very good configuration for your job on the survey. Okay, now we are doing the survey, and I will show you how to interface Delft Roadmap software to the gaps. I go in the gaps web MMI, and on one output, I select gaps standard protocol at 1 Hz and a transport layer as TCP server, but you can select also UDP or serial as you want. Then I go to Delft Roadmap project. In Delft Roadmap, to add an equipment, you have to go under navigation and do add equipment. In that example, the gaps is already added. I go in the gaps menu, and we can check here in the properties the connection details with the port and the data I want to have on the screen. Okay, now I can see in Delft Roadmap, as soon as I'm connected, I can check on the full screen the gaps and the GPS sensor. If I do a zoom in, I can see I have my gaps and my GPS. So in my example, the GPS position is the same as the gaps for the simulation. If I unzoom, I can have a global view of my survey area. If I go in a 3-dimension view, I can see here the GPS sensor, on the top of the vessel and the gaps which is deployed on the pole. Here, on mobile information, I can also read in real time few information coming from the gaps as the depth, the position, the heading, the date and the time. During the survey, you can keep this view all along your job and you can see the beacon, you can see the gaps and you can really follow up your survey. Our survey is now successfully completed. In these 3 videos, I'll show you how to take full advantage of all GAPS features. The easy and quick configuration, the unique antenna design, the embedded inertial system, the internal and seamless processing, the positioning performance even in challenging environments like shallow waters. On the next video, I will show you a set of tips and tricks to help you to get a better hand at operating GAPS systems. If you have any question or wish for more details about USBL solution, don't hesitate to contact us at support@xblue.com. We are on deck 24/7 and available all around the globe.